The natural logarithm function is defined like so, and it's valid for values of x which are positive. Use this definition and, making no assumptions about the log laws, prove from first principles the following. Firstly, log 1 is 0. So we have log x is the integral from 1 to x of dt over t. So ln 1 would be the integral from 1 to 1 of dt over t, and that has to be 0 because we have a 0 range of integration. We now want to show ln 1 over x is negative log x. So going from the definition, ln 1 over x would be the integral from 1 to 1 over x dt over t. It's suggested that we use the substitution u equals 1 over t. So du dt would be negative 1 over t squared. So du is negative 1 over t squared dt. Now look at the limits, and remember, since this is a dt integral, these are t limits. If t is equal to 1, u would be equal to 1 over 1, which is 1. If t is 1 over x, then u would be x. Now going from here, this would give me minus t squared du is equal to dt, and t squared would be 1 over u squared. So minus 1 over u squared du is equal to dt. So substituting, we have 1 to x. The 1 over t would be u. The dt is minus 1 over u squared du. So we end up with minus the integral from 1 to x of 1 over u du. And just by comparison, it doesn't matter that we've changed the variable. This is minus ln x. So now we have ln xy, which from the definition must be the integral from 1 to xy of dt over t. Let's just think about what this might mean. So we have 1 over t, and we're integrating from 1 to xy. So somewhere in between here, we can assume there's x. So this could be split in the integral from 1 to x of dt over t plus the integral from x to xy of dt over t. And clearly this part here is ln x. So we have ln x plus the integral from x to xy of dt over t. Now, if we use a substitution, u is t over x, which is given to me really by the fact that I want this one just to become y and this one just to become 1, then we can see that works with the limits. So if t is equal to x, then u equals 1, and if t equals xy, u would be equal to y. So when I come down to the next line, my integral now is going to go between 1 and y. Now, in this context, remember that x is actually a constant. So if we differentiate here, du dt, it's actually equal to just 1 over x. So that gives me that dt is equal to x du. So substituting in here, we need a substitution for 1 over t, and if we do that, rearranging this to give us 1 over t, 1 over u is equal to x over t, so 1 over t would be equal to 1 over xu. So we have 1 over xu for the t. Let's just tidy that up. This would be xu. And then our dt is x du, and the x's cancel. So we have ln x plus the integral from 1 to y of 1 over u du. And again, from the definition, again, we changed the variable, but it doesn't matter because we have the same thing. And that would be ln x plus ln y as required.